Alright, so now moving on to equation number 11. I'm going to go ahead and show this relationship here is true. We are in section 2.2 of this paper by Nelder and Wedderburn. Just as a reminder, the link to the paper and the complete playlist that I'm making for the paper are in the description of this video. So let's start here in equation 8. The second derivative of theta with regards to y equals 0. So let's start with what equation 8 is and why this equals 0, and then we'll build up to what equation 11 says right there. So if I scroll up, here's equation 8. Just a reminder, there was a typo here. This should have said the second derivative of L instead of Z. So I'll go ahead and write that down right here. And here's equation 8. And then there's that statement that this equals 0. So let's start with why that is. Remember, in this section of the paper, we are assuming the canonical link, which is that theta equals y. Okay, so when theta equals y, the derivative of theta with regards to y would be 1. And then if you were to take the derivative of a constant, so the second derivative, you would get 0. Okay, so there you go. That's how you get the second derivative of theta equals 0. So that means that this whole term here will 0 out. Okay, and so you'll be left with this piece right here. And then if we read it again for equation 11, so that is basically what you see right here. That's, well, actually, so there's a little bit more because this is the derivative with regards to beta, not to theta. So let me scroll back up. And we did show this right here in our earlier discussion, that the second derivative with regards to betas is the second derivative of y, of L with regards to y times xi times xj. So actually, let me go ahead and write that down here. This beta I, beta j equals the second derivative of the likelihood with regards to y, xi, xj. Okay, and we showed this prior in this playlist. We showed this relationship. So that would be this piece right here, since this piece zeroes out. So I'm going to pull that negative sign out front. Okay. D mu dy. This gets squared, divided by v. And then I still have that xi, xj in the back. Okay. And so that's basically what equation 11 says, but equation 11 says one more thing. So let me scroll back down to what equation 11 right here. We see that I have this piece and I have this piece, but I don't have this center piece. So the center piece, actually, if I just look up, let me go back up here. Under equation 8, says the expected second derivative with negative sign is thus this. So that means the negative sign should be here, and the expected second derivative equals this, which is exactly what equation 11 says. And so, again, that was something that we showed earlier in the playlist. We showed that this expected second derivative equals this. So there's basically saying that it, all three of these things are the same. Okay? So this also equals the expected second derivative. Okay?